Okay, thank you everyone for being here. We're going to start the session now on Research Data Management Systems, or RDMSs, a hands-on session on how to replicate data across similar systems. This is a companion hands-on session to the session that we had earlier today that I really cannot remember the name of. But it was a really great one, and you should look it up in the notes on Sketch or the Google Docs notes, because I think there are links to it in there. And this is put on partially by the Marine Data Cluster, myself, Matt Biddle, Carolina, Barry Gonzalez, and then also Carl Benedict and Matt Jones. And so what are we discussing today? We will have a very brief introduction of research data management systems, and then we will start off with two demos showing replication for Metacat and for RDAP. And then after that, we will go into some breakout hands-on practice time. If you use one of these systems, we will have both of our Matts, Matt Jones and Matt Biddle, that'll be here to help you to actually do that live right now. If no one really wants to do it, but instead would like to continue conversations that we've had earlier in the week, earlier in the year, we can go on to discussion questions. We have some prompt questions that we can ask. And so have you tested your backups recently? Your data is only really as good as the last time you've backed it up and that you've tested that backup. There's an adage that 1 is none and 2 is 1. If all you have is 1 copy and that goes away, then really you're SOL at that point. So in this community, in the ESIP community, I think a number of us have heard of RDAP and Metacat. You might be running one of these research data management systems right now. You may not know, or you may not have experienced using their features that allow you to replicate data between similar instances. So RDAP to RDAP or Metacat to Metacat. Oh, there it is. And yes, this is the follow-up session to data replication and repository succession, sustaining and preserving data for the long run. So what we are going to have is a couple of demonstrations of how to do that. And then if you'd like to get hands-on help from one of our Matts on how to do this, they are quite happy to help. And so I guess I have Matt Jones as doing the first demo. You're okay? I will stop sharing my screen.
What I'm gonna do is just sit up here.
Okay.
See if I can move that microphone to right here. It might work. Because it's hard to type on those Windows machines. Oh my God. What people do.
Wow. Can you hear Matt online?
Okay. Well, welcome. So this is a brief technical foray into the sort of guts of the Data One system and how we envision some very heterogeneous repositories might be able to work together to replicate data across the network. Just to briefly recap from my talk earlier today, Data One's a network of 68 member repositories that all run a really wide variety of software platforms. There's dozens and dozens of different software platforms that are in operation. And the replication system within Data One allows each of those repositories to set replication policies that let them move data from one node to another. So basically, that is enabled because data packages within Data One are represented as basically object graphs where each object has a persistent identifier. So we have a very firm handle on an immutable object that we can use to know whether or not we've moved that particular object from one place to another in the system. And the key to this is basically setting replication policy metadata on those objects so that the Data One system knows that it needs to ask one node to send data to another. So in particular, you might have a node like LTR that adds metadata to the Data One node that says that an object exists. And that might then request that the Arctic Data Center that runs a completely different set of software goes and requests, gets a replica, and lets Data One know that replication has occurred. And so once that's been done, then you can use the Data One resolution service to find out where each one of those replicas exists in the network. So that's kind of a summary. We're going to basically go through a Python Jupyter notebook, like as if we were an end user who had contributed a data set. There's, like I said, there are dozens and dozens of different software platforms that people use to contribute data to the Data One network. I'm working with the Metacat platform, which we develop and use in-house. As I said earlier this morning, there's about 15 to 20 repositories around the world that use this. And so it's kind of a shared ecosystem that a bunch of people use, but it's by no means uniform. Like there's lots of other types of software in the Data One network that can also make use of this, this replication API. As a matter of fact, the core thing that you need in this, as a repository to participate in the system, the core thing you need to be able to do is to publish these replication policy documents in the objects that you're publishing to the network. So that's the core thing you need to be able to do if you're so yeah. So I'm gonna switch back to the notes for a real quick sec. If you look in the resources section of the notes, I have some links in here. There's a Data One GitHub repository link, a KNB test server link, and then a link to my overview slides. So the slides are the ones I was just showing, if you want to sort of get that big picture. The GitHub repository basically contains a notebook, some data, and a configuration file for an environment. So for those of you who want to follow along later, like this, you could clone this repository or download it through a zip file and open it up in your disk. And then basically this has everything in it you need to do what I'm about to show being done. In addition, because I don't really want to push a bunch of garbage data out into the real production network, I'm going to be working on one of our testing nodes. So we have this is a replica of the KNB data repository that just holds test data. So this is one of our testing nodes, and it's kind of just a sandbox that you can put any kind of garbage in and it will just get cleared periodically. So you guys are free to create data sets in this KNB test node. The address for that is in the link in the GitHub notebook, and you can push data into it and then get data back out of it. But don't expect anything to stick around there for long because it's just a development server. Okay, so with that introduction, I'm going to switch over to the notebook. And so this Jupyter notebook that's in that repository basically walks through the process of doing what I just showed in the slide and basically creating a new replication policy for a data set. So in order for this to work, the first thing we need to do is to create a virtual environment that has the requisite software packages. So Data One supports a wide variety of different languages, but we have client tools in both Python and R. So there's a Data One R package and a Data One Python package. So the two software dependencies we have are data1.cli and of course the Jupyter notebook kernel stuff. So basically this just sets up using UV to set up a Python environment that has those two packages installed in it. So if you just opened up that D1 replication demo repository and then run something like UV install or Poetry install or one of your package managers, you should be able to get a replicated environment. In addition, in order to demonstrate replicating a data set, you need a data set. And so the first thing that you'll need to do is to go and log into this test node. So if you go to the KNB repository, you can log into that repository using an ORCID identity. And so you can sign in with ORCID. If I go over to my browser, go to the KNB repository, I'll hide my video here. Yeah, so I can basically, I'm going to go ahead and log out real quick just to show this process. So you click sign in up here on the KNB, you sign in with an ORCID account. This prompts you for your ORCID username and password. If you haven't already got an ORCID, you can just follow that link to register for one. But basically, any ORCID identity will allow you to log into the Data One network. Once you're here, in the profile menu up here on the right, you can see my name. If you go into my profile and then under settings, there's this authentication token. This is an API key that allows you to act as your identity within the Data One network. And so if you copy this API key, then you'll need that in order to run the Python demos and act as the person with that ORCID identity within the network. So I'm going to copy that API key, and we're going to use that when we're creating things. So what I'm going to do with that API key in particular is in the notebook, we created this JWT key file, and we're just going to drop that key into this file and save it there. So I'm just going to save that in that file. So it's just a one-line file with that API key. And we're going to use that in the Python script to authenticate ourselves. So that's this section about using and saving your API key in the notebook. So once you've done that, then we need to create a new data set that we can use for replication. I'm not going to create one right at this moment. I created one just a little bit ago. So this one right here at the top is this data set this test data set I created. It's basically a small data set that has one CSV file and one PNG file in it, and a little bit of the minimal metadata I needed to create that. The key that is here is that at the top of this landing page, you can see there's a persistent identifier, in this case, a UUID. I'm just going to copy that UUID because that's the key to this particular data set that lets me access it through the Data One API. So we're going to access that from our Jupyter notebook. And what we're going to do is we're going to start by just changing the replication policy for the metadata document. But you could also change the replication policy for the CSV file, or the PNG file, or all the other components of the package. So one of the nice things about this API is that you can have a different replication policy for different parts of your data packages. Like it's not a one size fits all. Like you could have, one section of your data package is replicated to 4 different servers and one is only maintained on your own server for some reason, right? So there's both access control and replication policies can vary per object in the Data One network. So back to my notebook, assuming we've created a data set, so I walk you through that up top. We're going to basically go through, and there's some code blocks in here for initializing the client library and then creating things. So the first part is just importing some of our code. So we're going to import our repository client and our Data One client, and that should load those libraries. And then this first section basically loads our authentication key from the file. So this first block, opening the JW key, just reads that into that string into an auth token. And then we set up a dictionary and we open up a Data One client library using that. So this basically, if I run this block, this gives me a variable called repo that's a reference to that Data One KNB test node. So we can use repo to basically call API methods on that. And it's authenticated using that auth token that we saved in the file, so we don't have to do that every time. In addition to the KNB test node, we may want to authenticate to and talk to the Data One network overall. And so we call the Data One, there's a set of coordinating services that we call the coordinating node. And so you can get a reference to the coordinating node using the same pattern, basically setting up this D1CN client. And then I'm going to go ahead and do that. And when I run this, I can also echo my credentials and see that Data One does think I am indeed logged in with my ORCID. So it's the authentication, that sort of just verified that authentication worked. So I'm not going to really dwell on that very much. But there are a lot of functions in both the member repository API and in the coordinating node API that you can use to help manage content across both your node and across the whole network. A couple of things in this notebook I put in here. You don't have to worry too much about this. I wrote a couple of utility functions just to print things out a little bit more nicely in the notebook. But the core of this demo is basically this one function, which is change replication policy. So I wrote a little function that basically runs through, and for any given object with a given persistent identifier, it changes the replication policy for that object to basically to require a different number of replicas and to basically tell it where we want it to replicate to. So another node in the network. So this basically takes the repository that we want to change, the identifier of the data set that's coming in, and the number of replicas that we want created in the network, and then an optional list of repositories that we want the data replicated to. So in this case, we're going to set this replication allowed field to true. We're going to set the number of replicas to the number that was requested in the function call. And we're going to set the preferred member node to the only replica node that exists in this whole replication in this testing environment, which is this MN stage UCSV2. So that's the extent of this function. And you can call it by basically, I can just paste let me go back and make sure I've got the right UUID here. I'm going to copy my UUID from here, and I can just paste this in here and run this change replication policy. And what that did is it went through and it first looked at and printed out the information about that object before we changed the replication policy, and then queried and got the information about that object again after we changed the replication policy. So the original object, is a EML document with a certain size and checksum. And you can see it has an access policy and a replication policy where replication allowed was set to false. But then after we made our change, we now have an updated system metadata document. All the things are the same, except now we have a replication policy that's set to true, and one replica has been requested, and we requested it happen on this particular node in the network. So it's a pretty straightforward thing to change the policy metadata. Of course, you don't have to do this in Python. You don't have to do it in any particular programming language. This is just a metadata change that you can make either through this API. If you're a member repository that's contributing data and metadata, you can add this policy metadata as you're uploading stuff to Data One in the first place. So you don't even have to do it separately, right? It could come as just part of your normal sort of synchronization with Data One. So this is just basically showing how to do it one object at a time, just to explain the process. So you notice that right now, although the replication policy is set to true, this list of replicas of this object is blank. And that's because we hadn't had any before, so there were no replicas there. So we can then go in and just requery the system and ask for that system metadata about the policies again and review that document. And we can see now that in addition to that replication allowed being true, we can now see that there are 3 replicas of this object that exist. There's the original version that was on the test KNB site. There's a version of this metadata file that was replicated to the Data One search system. And then there's the version that we requested be put onto on the MN stage UCSB node. So that's basically, it's a straightforward process. Behind the scenes, there's an entire orchestration system that lets Data One talk to lots of different types of software stacks and handle that. But we basically mediate all the differences in those software stacks by having a common API and some simple policy metadata about replication. So from a client side, like basically saying, I want this data replicated, it's very easy. From a server side, like if you're a node that wants to offer replication services to other members of the network, you have to be able to accept whatever types of objects that particular node wants to send to you. So if you can only store netcdf files and you can't handle Parquet files, say, then you wouldn't necessarily be able to accept everything that's coming. But you can write a node replication policy that says, I'll accept this kind of content and I'll accept this much of it. Like, so, you can have file size limits on what you'll accept. You can have total size of like how much storage you're willing to dedicate to replication and stuff. So nodes have a lot of control over what they're willing to replicate. We're really trying to find additional repositories. As I said in my talk earlier today, there's about 10 nodes out of the 68 in the network that are offering replication services to everybody else. We'd really love more groups that are supporting the network to offer replication space so that, if the worst things happen, there's the high availability and failover option for all these digital objects. The last thing I'll say is that the Data One data package is a very generic data package. It's basically a directed graph using persistent identifiers as the nodes of the graph, and the edges are the relationships among all the components. And so every object within the system can be represented regardless of type. That makes it a very generic system, but it also makes it, there's only a limited number of things we do. Like, we don't work on things like data access. Like, if you replicate data to a Data One node that's in the cloud, it very well might be that endpoint that got replicated to could then be used for like cloud-based access. Other nodes in the network might only give you access to, like, they might have a relational database that they're storing it in, or they might have something else. So who knows where it's going to end up, when you request different things from all these diverse different nodes. But you do know that there's a copy there that can be retrieved through the Data One API endpoint from any of those locations. So if you wanted to replicate an entire package, like here's a quick curl command that I wrote that basically just queries for that identifier that was right there. This just basically queries for that and just lists all of the identifiers of the objects in that package. So you'd want to work through each of those different identifiers and set the policies, both access control policies and replication policies for the different objects in your data package. This lets CCAN, Metacat, Dataverse, GeoNetwork, all these different providers all interoperate using a common sort of system metadata model that we wouldn't have without the Data One network. So that's it for the demo, and I'd be happy to take any questions. If people want to work through it and try to get things running themselves, they're welcome to. After Matt runs through his demo, we can come back to that and try to do that. But yeah, so I don't know, questions, Joseph, or do we want to just switch straight to Matt?
Do we have any questions? Sure. Hold on.
Hi, Matt.
Hi, James.
I'm James Gallagher from OpenDAP. Yeah, I was wondering, how does Data One deal with a data set that changes fairly frequently? Like, suppose, for example, a data set updates values on a daily basis. Can that data update in Data One on that daily basis, or does it need to handle it over a longer time span, like a longer time lag?
It can. Data One is definitely more focused on immutable snapshots of data sets at points in time. But there are a lot of groups that have, for example, automated sensor systems where they're depositing a new hourly or daily or weekly file into a data set and then attaching that to their data set through an API like this and then updating it. And so as long as, that we basically have a round robin approach to our harvest. And, we may not know about your data set. If, for example, like there's a large repository over in Germany, so Pangea, they have a massive number of data sets. They have, I think, almost 500,000 data sets now. And so that is when we go to harvest Pangea, sometimes it takes us quite a long time to get through that whole thing. And that can provide a little bit of a delay between some other, repository that we're trying to rebuild our index around. We work pretty hard to try to not harvest stuff that we've already harvested. So we have a lot of rules about immutability that lets us say, we've got, 1 million data sets in the index now. We don't want to know about any of those million. We already know, we only want to know about the changes, right? So we try hard to not reharvest stuff that's already been harvested, but not all member repositories are very good about reporting immutability. So sometimes we end up reharvesting stuff because we just don't know that we don't already, we find out once we've got it, we can check the checksum. We're like, oh yeah, we already have that. But so yes, you can do a lot of them. We're I would say in general, handling data packages that have lots of objects, like say millions of objects, is definitely more challenging in this model. And we've been working on a new data package sort of framework that allows us to not have the centralized manifest that we have today. So our listing of data package contents is very similar to like the RDAP datasets.xml, so ours is an ORE document. But that doesn't scale real well when you get to millions of objects in a data package. And we're moving more to a distributed, each file can assert which data packages it's part of model, which lets us do more. But we'll, yeah, we can do it both ways. Yep.
Any other questions in the room or online? Okay, thank you, Matt. And we'll move straight over to Matt.
All right, I'm gonna try to do my best. Can you all see my screen all right?
Yes.
Okay, cool. Hi, I'm Matthew Biddle. I'm with NOAA's Integrated Ocean Observing System Office. I'm just gonna do kind of the same thing that Matt did, walk through the little bit of the presentation I gave earlier today, and then dive into an example of copying a data set between two RDAPs. So I sit on the RDAP Strategic Insight Group. I've been an RDAP administrator for a few years. I would say I know enough to be really dangerous, but I know enough to talk to you all about how to do this replication thing with an RDAP system. But there are definitely a lot of features and a lot of things within RDAP that I might not be the expert with. And I did see Rich's name somewhere on a document that he might be in the room, and he might also be a good resource in this presentation or in this session. I'm not going to talk about that. So RDAP, if you don't know what it is or you didn't attend the session earlier, it's an application you can install. It's a data broker designed to deliver data and metadata from any data source to the user's favorite client software. So you're not ingesting into a specific database. You go from your source data, you develop this configuration, and then it allows access in whatever format might be useful to the user. It was originally developed by Bob Simons. He retired in 2020, but then Chris John came in, and now he's the RDAP technical director, who's really been pushing it into the open source community to allow for a lot more contributions and a lot more development. And it helps us with meeting FAIR principles, and there's a whole slew of documentation on GitHub. So the requirements to install RDAP are Tomcat and Java. But there's a Docker container, and I'm actually going to walk through that. I was hoping to be able to give a demo of actually pulling the Docker container down, spinning it up, and having an RDAP to work with right there, but I just didn't have enough time to get it. But I can at least walk through how to do that and where we're at. There is a quick start guide, and that's what I'll walk through a little bit later. And the brains of RDAP is this datasets XML. That's where the configuration is for each individual dataset. It's where you can add in metadata, you can make virtual datasets, you can point to other datasets, which is what the example that we'll dive into later today. A lot of people are using it. I think you all have heard the name float around in some capacity. And yeah, we meet FAIR principles. So what RDAP does is it has these different classes where it can read data from. So these are the readers, and then it has these standardized output format, or it has standard output formats, depending on how you configure it. Some of those are standard formats like netcdf-cf, and some of them are just CSV tables and things like that. We will be working today with EDD table copy an EDD table from RDAP. So I don't know if you can see my little teeny tiny mouse, but those are the two readers that we're going to work with today to show you how to pull from an RDAP and develop and have a copy in another RDAP. I forgot my timer. Shoot, sorry. The RDAP allows you to federate from other RDAPs. So you can basically have one RDAP that points to a bunch of different RDAPs, and that request actually goes to those source RDAPs. So that federated RDAP doesn't host any data on it. So you can have a really small system that actually points to a bunch of individual RDAPs on the other side, and nothing resides on that machine. But what we're going to talk about today is this remote replication of data set. There's a bunch of different ways that we can do it. We can kind of go about it in a whole bunch of different ways. But what I'm going to actually dig into is the EDD table from RDAP and the EDD table copy. There's also a capability to cache from URL that I actually tested a little bit like a week ago with a colleague from NCEI, where I was able to pull a data set from NCEI into RDAP and share it without actually having to download and do all that. RDAP did it all for me. So those are the two examples I'm going to dive into. And now I'm going to dive into my my demo. So what I've tried to do, I've tried to do way too much. I've laid out the guidelines for how to actually go through this process. I've been thinking about it a lot because my community that I use, regional associations, there's 11 of them. They all have RDAPs. And I've been thinking about, okay, well, what happens if disaster comes about and we need to like move all this stuff? Well, RDAP's a standardized piece of software. Can we leverage that to copy data, move things around? So what I did is I pulled up this documentation site about how to do some of these different copying features. I've dropped the link into the notes document, so it's accessible for anybody who, if you want to go ahead and do it. But the idea is you start with identifying that RDAP data set that you want to replicate. I got an okay from Nanus and from Senku's to copy data sets from theirs as this example. First and foremost, what you should have is a conversation with the administrator to make sure we're not just copying stuff willy-nilly. The capability here allows you can really go hog wild and copy a lot of data. So we really want to work with the administrators to make sure they understand what's going on and we understand what it is that we're doing. To set up an RDAP, there is that quick start guide that I mentioned before, but these are the steps. So I have mine spun up on an AWS EC2 instance. There's a lot of documentation about how to get RDAP up on a web service on AWS. And I don't know what information you all need to, like, if I was going to go buy a machine on AWS, what do I need? I just dumped a bunch of information in here. So if that's helpful, that's helpful. But on that, you need to install Git, need to install Docker, Docker Compose, and then I use MiniForge to manage my Python environments. That's just to do some other stuff. But then once we get in there, we clone the RDAP Gold Standard. So what's in the RDAP Gold Standard repo is basically your bare bones spin up of what an RDAP instance should be. So you have a Docker Compose and you have a couple other configuration files. You have a generate data sets. You also have this is like the bare minimum to spin up an RDAP. I've actually run through this whole process from installing everything all the way to Docker Compose upd and having a local instance of RDAP up. I did it in like less than 30 minutes. So it's really quick. It wasn't too difficult. I can't do it on a GFE because I can't install Docker and it's really frustrating, but I've been able to do it on other machines relatively easily and quickly. And so I'll go over to the next section. So we're going to talk about that datasets.xml. This is like the brains behind RDAP. This is the thing that explains how to read data, how to use it, how to add metadata, where different columns are, things like that. So what we're going to do is we're actually going to build a little chunk of datasets XML. What I have here is a list. I'm actually going to expand this. I have a list of different ways that we can copy data sets within RDAP, or at least link to other data sets. So this first one is linking to an existing RDAP. And what this does is this basically says my RDAP is just going to point to the other RDAP, and I'm not going to actually host anything on my local machine. And so within our datasets XML, and I'll pull up an example of what a datasets XML looks like. They're pretty gnarly, to be honest. It's a pretty gnarly XML file. It's got a lot of stuff, but there's like header information where you can identify, the license and your different IP addresses and the main configurations. And then we get down to the actual data set nodes. And this is where you're configuring an individual data set. And within those, there's different configurations depending on which EDD type you're using. If you're using a grid, or if you're using a table, if you're pulling from an RDAP, if you're reading a netcdf, there's all sorts of different stuff. The documentation online is really great. It's super helpful. And so if you're in this world, I highly recommend taking a look at that because it will help understand what all of these things are. But within that XML, you're going to identify the little snippet that you need for your data set. So typically what I do is I manage my snippets in a data set by data set. I have them as individual files, and then I smash them all together into one giant datasets.xml that RDAP reads. There's a slew of different ways that people manage it. Sometimes they just work with the giant XML file, but I like the individual pieces. So to use this EDD table from RDAP, again, I'm not copying any data. I'm not doing any, I'm not bringing anything locally. I'm just having my RDAP point to another one. So we just set up our data set as using EDD table from RDAP. We give it a data set ID. So what I like to do is append on that specific thing when I'm doing these type of copying efforts, and then set it as true, so it's active within the RDAP. And then we just say our source URL is actually the URL for the data on this Senku server. So if I hop over there, we can see that here's that data set on the Senku server. So now in my RDAP, and I'm gonna do one more flip. I hope I'm not doing too much. So what I'm at now is I'm on that AWS instance. I'm sitting over on a cloud server somewhere in the ether, and I have my Git repository where I copied over that gold standard, and I have my RDAP actually up and running with Docker. And so I'm gonna look at and of course I waited too long, so I'm gonna get a timeout. Anyways, I'm not gonna do that right now because I'm gonna wait for it to re-sign me in. I knew this was gonna happen. Darn it. So anyways, I dumped this data set snippet into my main XML, and then I tell RDAP to reload it. It has a flagging capability, and now we can go and take a look at I have this RDAP where I'm sitting, and now we can look and see, hey, I have that exact same data set now on my RDAP. So my RDAP doesn't actually have any data on its server. It doesn't have anything sitting there. All I'm doing is I'm pointing when I do the data call, the request to say get HTML. This request is actually going to the Senku server itself and pulling that data back. But my local one isn't doing that. So that's one way that you can just at least do a synchronous replication, a synchronous view of another data set. But what I really want to dive into is that's the foundation for what we're going to dive into next, of using how to actually physically copy a data set from an RDAP. So I have a Jupyter notebook, and of course everything disconnected. Jeez, come on. I'm going to try to get this connected here too. So this is, again, my RDAP. I got a lot of windows going here. And I want to activate so we can look at the file when I do copy it. Okay, so I wrote a Python notebook to basically build this XML snippet. So we use EDD table from RDAP. That was the example I showed before, but we're going to wrap it in this EDD table copy. And what EDD table copy is it's just this extra piece that tells RDAP to actually go and download the data from this source URL. So what I do, so now that I know how the XML looks like, I can actually build a script that goes out and looks at an RDAP and pulls down all the data set IDs and builds this XML. So what I did here is I wrote just a quick Python notebook that using RDAPy, however you want to say it, to look for the Senku servers and then give me all the data set IDs. So I'm looking for all the the table DAP data sets and the time series data sets. And then I'm returning all of the, I can't really see it here. I don't know if it's over here. You can get all the data set IDs out of it. And so knowing that, I can build these little XML snippets for each of the data sets on that RDAP. So I have this, I create a template where I'm using Jinja to basically build that XML file. And then, so here's that Jinja piece where I'm building the XML and I'm inserting my information about that specific data set. And then it spits out, what the XML that I need for RDAP. And so I can create it for each of them. I created 171 files on Google Colab. They're all sitting here. And so I can load those files into an RDAP. These are all those snippets. And so I can concatenate them all, stick them in datasets XML, and it'll start loading them. So what that looks like is if we look at this content, RDAP content. So I'm going to look at, this is my actual live datasets.xml. So if we go up to the top, there's all this configuration stuff and the HTML, and then we go down to, here's where we start identifying a data set. So we have data set. So here's where we identify one of the data sets. I'm actually going to go to the very end of the file. So here's the very end of the file. So now what I want to do is I want to copy this RDAP, this data set off of the Senkus RDAP, the San Clemente Buoy data set. That's where I grew up. So that's why I wanted to do it. And I'm telling RDAP, hey, using EDD table from RDAP, go to this URL and actually make a copy of that and put it in the data set EDD table copy. And so what RDAP actually did is it went out to that URL and it, RDAP data copy, it made a copy of that JWS San Clemente file. So if I go to CD RDAP data copy JWS, so if I look in there, there's a file that's called x0.nc. What I decided to do is I decided to use, there's a specific configure in here that is extract destination names, and that's what it calls the netcdf file that it downloads. So when RDAP goes out and grabs a data set, it grabs it in netcdf because that is the most well-documented version of the file, regardless of how it's organized on the RDAP server that you're getting it from. So it's always going to go and grab a netcdf file and download it to your local system. So if we do ncdump -h for x0. So now we can see there's a netcdf file in here that RDAP went and downloaded, and it's got all sorts of data in it and a whole bunch of metadata. And now we can flip over. So I flagged that for reloading, and we can pull it up. And now this is the data set on the Senku server. And since I used that same identifier, I could look for it on my server. Hopefully it loaded. Hey, it did load. So the thing is it takes a little bit to load. It has up to like 15 minutes to go and grab the data, but once it grabs it, there's a flag in there that you can say update it this frequency. So if it updates frequently or not. So now I have a physical copy of this on my server. So if the Senku's dataset goes away, my server will still have this dataset in its current state at the most recent version of whatever it was that I grabbed at it. So, and the configuration is relatively simple. It's just this little teeny tiny bit of XML. As I said before, it can get really tricky if you just go hog wild and start copying stuff because RDAP made it so simple. So that's something to keep an eye on. But then there's also these other capabilities of cache from URL. So you can go out and I just wanted to show the XML for the NCEI data set. I have another one. Oh dear, this is going to take a minute. So I have this sort of this is an example where I had a colleague who has some data over at NCEI, and he was like, could you make this available on RDAP? And I'm like, oh man, I got to copy it over. I got to put it on my server. I got to figure out how to get it. Well, no, I didn't really have to. I can use this cache from URL. RDAP goes out and downloads the file to wherever you specify, and then you just have to set up the rest of the configuration. So this is me adding in metadata because that data file is just a text file. There's not a lot of metadata associated with it. So I went in and I added metadata about attributes, long name, you know, all the units and all of that stuff to make that text file a little bit more accessible. And I was just going to show that example. Right here is this. So this is the data set that I pulled. Here's the source. Sorry. Anyway, you get the idea. The source was just a text file. There wasn't a lot of detail there, not a lot of metadata, but through RDAP being able to copy it, configure it, I was able to add in a whole bunch of metadata to make it a little bit more fair and accessible. Again, there's also the potential, since RDAP has the consistent RESTful endpoint, you can also write Python to just do a manual hard copy of data, and you can download it all as netcdf files and do what you need with it. That was originally where I started until I found out about this EDD table copy. And then the last part is just details about how to load a data set using a flagging system. And then this is my trick to not have to deal with a whole bunch, a giant long XML file. I have this script to insert where I have the individual snippets, and I wrote Python to be able to shove the individual snippets together into a giant one. I think that hits all the points that I wanted to talk about. And then at the very end, there's some examples on, you can do a comparison between what all the different files look like. I went over, I apologize. I hope people are still awake.
It's entirely okay, Matt. Thank you very much. Do we have any questions? Rich, who is in the room?
Hey, Matt, that was cool. Like on the system that you copied from, it could be like a collection of CSVs or something, and then on the system you copy it to, it ends up being a netcdf. So could that be more efficient then for access or whatever? Or is that, I mean, could you also use this kind of as a way to make everything more efficient?
Right. I mean, you could go and grab all the Parquet files, right? And then just not have, yeah, I mean, that's an interesting way to think about it. I haven't thought that far ahead.
Yeah, that was great to see, Matt. Thanks. This is Matt Jones. So if somebody has, say, replicated the data set from one RDAP server to another, and a group like Data One was harvesting both of those RDAP servers, is there a way that we could tell that they're the same data set without like checksumming every single file? Is there provenance metadata anywhere that tells you that this was derived from something on another machine?
That's a great question. And no. And I think the intent there is, if I remember the documentation correctly, the intent is to reflect exactly what it was that the original provider was providing. But I'm just trying to look through. This is one of those examples. That's the 80. I want to see the copy. So the copy, I want to see if there's anything in here that tells me this is, actually, yeah, here we go. So there's a history attribute that RDAP updates, it looks like. Yeah. So I believe there's a history attribute, but if I recall correctly in the documentation, there was a very very strict call out to like not editing existing metadata to appropriately reflect the provider's metadata and what it is that they're, because to ensure appropriate provenance and citability.
Yeah, that's great. That history thing is probably enough. It'd be cool if it were in a you could probably have a separate attribute in your NC global section that would actually use like a prov predicate to say this is derived from one of those URLs that's in your text field there, right?
Well, there's a GitHub repository that you can put an issue into if you're really
Absolutely.
interested.
Okay, any other questions? I know it is Thursday afternoon, so thank you to Matt and all of you for sitting here. I guess we still have about 35 minutes of time. We can continue with discussion for a little while. Maybe at least say until 5:15, and then we all flood down and get free drinks at the bar. Sorry, Matt.
I got free drinks in my fridge.
Yeah, so we are technically in practice time now. If anybody, or let me rephrase this. Does anybody actually want to try to do this right now with their own systems? Or when it's just, of course, Rich. If anybody wants to do it, it's you. Well, who do you want to tap first, Matt or Matt? Okay. Otherwise, I mean, I have some discussion prompts here, since we have James Gallagher in the back of the room, can OpenDAP do something similar to what we've seen with Data One and RDAP? Let me bring you the mic too.
In short, no. Not moving a data set through the server itself. That you can't really, in the general case, you can't download the files behind the data set. But Hyrax and I believe TDS as well have a method where you can say, okay, for this data set, I would like to this particular granule, that is the file, I would like to have all of the values packaged up in a, say, netcdf4 file, and I would like to have that. And then you could get that, and then you could stage that in front of your own instance of Hyrax or the Threads data server, and that would be a form of replication. However, there's no formal replication notion as there is with Data One. Nothing anywhere near that sophisticated, nor is there any attempts to say, or to put it more, to leave the narrative world, no notion of associating provenance to say, oh, well, this particular thing came from this other place and it's a copy. It's a value preserving copy. So there's no concept of that in the OpenDAP protocol itself. That was a long answer for them.
Thank you. Yeah. Are there any systems, RDMSs, that participants in here would like to see some sort of replication demo on? And I can throw something else onto my list of things to do and try to track down Invenio, CERN, to see if they have something, or going even further abroad into DSpace or something else.
Another system that people use a lot in Data One is the Dataverse platform. And my understanding is Dataverse has a replication capability as well. And so like Harvard Dataverse, which is one of the main nodes, replicates a lot of data from many other Dataverse nodes around the country. So it's a fairly similar conceptual network to Data One in that regard, and another whole ecosystem that does that.
Yeah. I guess since I have you in the hot seat, how many other consortiums, organizations, communities have some notion of replication? Like we could imagine Data One network is sort of one, Dataverse network as another one, something similar with RDAP. I can go out and ask Claude to do some research and try to find that out and sort through the answers first. But since we have an expert in the room,
Well, I wouldn't say I'm an expert in this, but I would say, I think there are lot of groups that are focused on distributed systems where replication is a key part of what they're doing. And, you have all these software systems like Zookeeper and other things that are basically focused on building distributed data systems with reliable eventual consistency across the copies. So it's a very common technology. I think what's different about, for example, Dataverse or Data One is that we're focused on doing this across a pretty generic set of, it's not like requiring a particular software stack be run in order to do it. So you don't have to have a Zookeeper node, or you don't have to have, any other distributed technology working necessarily. It's a pretty lightweight metadata model to sort of handle that. So, but I think that this is a super common pattern to have distributed caching. Yeah, there is, in the high energy physics world, they have a data server called XRootD that does something similar, where they have origin servers and caching servers. And the caching servers are meant to basically be able to take large chunks of data from any given origin server and bring it proximate to a compute node that needs that for a while. So like they use this for the CERN basically uses this for all the both LIGO and the other big experiments where they have to move 400 terabytes of data from one node to another to do compute, and then they have to move it back, and they can't keep it all on the same node that they have their compute on. So yeah, so like those guys, like they have big data. I've never encountered, the papers I've read from the high energy physics community are truly mind-boggling about how they're doing that.
Yeah, apologies if this was already covered in either your earlier thing today or in the prior session, but how is is there any like global tracking of the replication, or is that not covered, of how many copies there are of a data set in the network? Is that managed in yeah, within the Data One context?
Yeah, so for Data One, yes, so the individual repositories publish a replication policy, and then the Data One network makes sure that that happens, and we keep track of where all the replicas are. So we know where they all are, and we can report. There's a resolution service that any person can call the Resolve API and find out what the web endpoints are for any given file that they want to access. They can find out what the current web endpoint is for that. In addition, we have an auditing service that goes through and checks. We found that over time, like when you look at decadal timescales, a lot of the nodes that agree to do something don't hold up their end of the bargain over time. So when you're talking about these long-term archival systems, they tend to like deteriorate. And so we have an audit system that will go out and notice that so-and-so said they were going to replicate this. They used to have a copy. They no longer have a copy. And then Data One makes sure that there's another copy created somewhere else to fulfill that replication policy. So it's like meant to be basically a fairly automated system for ensuring that there are, for example, 3 copies of some critical system spread out across nodes in the network.
So there are some Data One managed nodes that are the replicator of last resort. Is that like if someone says, "Oh, I want 10 copies of my thing," and there aren't 10 people out there willing to do it?
Yes, we do operate 3 replication nodes right now in 3 different geographically distinct data centers, specifically to seed this and make sure that people had a place to do it. There are now, like I said, roughly 10 nodes that will accept replicas across the 68 node network. We'd love to get more. We do not have capacity to replicate even a tiny fraction of the data sets in Data One. Like you look at like NCI has 35,000 data sets in Data One or something. Ken Casey told me it was about 2.5 petabytes of data at one point. There's nowhere near that much replication capacity in the network. So if a group like that were to suddenly turn on and request replication, we'd be sunk. So it's working well for the long tail and for mesoscale data sets or for a small number of larger data sets. As a network, I think we could scale it because it is sort of like meant to scale with the number of participants. Each member can add capacity, but as it stands now, I would say we couldn't handle a massive amount of replication. We've got to get some other people in the network to step up.
Okay. I
Oh,
guess
I was gonna jump in really quick. So the Global Biodiversity Information Facility has a tool called the Integrated Publishing Toolkit, and they run kind of a node system where a bunch of people host an IPT, and then different aggregators like the Ocean Biodiversity Information System and GBIF will pull from those individual IPTs. So as Matt said, I think there are a lot of groups that are doing it. It would be good if all of those groups got together and we talked about how to do it. Similarly with acoustic telemetry community, they have a node structure as well, and they have a bunch of Python tools where that's how they're exchanging data and exchanging packages. They have like a regional node structure, so there's a couple in the US and a whole bunch internationally, and then they have the aggregation system that's up in Canada where they bring it all together and then do meta analysis on it all. So I think that, as Matt said, there are existing entities that are all doing similar type things. It would be good to get them all in a room to talk about this.
sounds like a good proposal for some funders one day. Maybe a Gordon Research Conference. That sounds like a good idea. I guess let's just do the last question really quickly. Say lossy specialist to generalist repository replication. Let's say, like the Data One network is going down. Is there a way to say shovel everything into Zenodo? Or at least all the things that fit into there quickly? I'm thinking about this from myself working with an automated script to move things from NCAR into Zenodo. And at least there's a copy there. It's not perfect, but the data is there. There's at least partial metadata. We dump our XML files, so it's there, but it's not the XML file is in the data set, but it's not represented in the attached metadata that you might harvest for a knowledge graph.
Yeah, it's basically the same. The Data One network has these different disciplinary metadata standards that Zenodo doesn't know how to deal with. Zenodo has a very lightweight bibliographic metadata standard that lets you do some simple attribution, which is great. But you could dump, an ISO file or an XML file into the data set to preserve it. Like Matt was saying yesterday, we support Baggett download. So I think if you were trying to if there were a node in the Data One network that was going down and you wanted to export it all, I would probably iterate across the get package interface, grab a Baggett archive of every data package and deposit that into Zenodo, which should have everything that we know about that in all open formats inside of that Baggett archive with checksums on everything and all the metadata in there. So that would be a very good preservation package if you wanted to put it, whether it's on an FTP server or in Zenodo. Like Zenodo's like an FTP server with, some bibliographic metadata about stuff, right?
I guess the same for you, Matt. With RDAP, maybe this is just a script that could be written, hit button in case of emergency.
Yeah, there's actually built into the system. So like every day I go into the documentation, I find something new about RDAP that I didn't know about before. But there was a tool built years ago called Archive a Dataset. And I can do a quick screen share. But that allows you, and I think I talked about this earlier today as well, but you can script this whole thing. You can where is it? So there's a shell script that you can do to archive a data set, and then you can feed it I want to create a Baggett package, and then you feed it the data set ID. So you can wrap this in a script that says, for all the data sets in my RDAP, run this, and it'll generate a tar-gz of that data file, and it'll create a SHA of that tar-gz. Inside of the tar-gz is the whole Baggett package. So you have the metadata associated with it and all the SHA checksums. And then you can identify what file format you want it to download as. So you can download it as TSV or as netcdf. That's up to the user. So there's a built-in tool within RDAP to do that, but that would take the administrator having the forethought to actually do this ahead of time and then make that available. So there is that little caveat there. But yeah.
Does that round trip from Rich?
Does that round trip?
Can you load the Baggett archive back in?
Oh, I am so glad you asked that. I did that because so I'm trying to push NCEI. I hope nobody, or well, I hope if NCEI is there, I'm trying to push you guys to read data straight from RDAP. So I did do that. I said, hey, NCEI, can you archive a data set? And I served it back out via the files system. Oh, I deactivated it. It's no longer active. I can make it active again, but it's going to take a minute. But basically, I took that tar-gz file and I made it accessible via the RDAP capability to serve just a file itself. So you can serve out like zip files, or you can serve out other asinine formats that might not be readable by other thing as just a file with a URL. So kind of like a web accessible folder. And so that's what I did is I had the data set in RDAP, I did archive a data set, and then I made that archive a data set accessible. It wasn't baked into the system. That could be something that would be interesting to see if that's worthwhile exploring. But I was able to do it on like a back route, I guess.
Thank you. I'd like to thank both Matt and Matt again for the demo and answering all of our questions. And we will end this early. You have about 3 minutes to go downstairs and grab one of the 15 free drinks I think they have at the beginning. Thank you, everybody, for showing up.
Thank you for hosting this, and thank you to everybody in the room, however few or many there are.